All right, welcome everybody. Today we're going to be talking about operators in C++. We've talked about them a little bit before. We're going to go into more detail. And we're also going to talk about constructors because the two concepts, again in more detail, the two concepts go together really well. So, we have talked about using operator square bracket before, but what if we wanted to make a type that behaves somewhat like, let's see, let me move to the other server. What if I wanted to make a type that behaves like an integer, right? Like I wanted to make a type that behaves like an integer, but always make sure that it's initialized. Because that's one of the big problems in C++ is uninitialized variables. The fact that C++ allows you to have an uninitialized variable is just something that just kind of galls me. So let's see here. How about that for you guys? You see that? Okay. All right. So we're going to make a new class today. Let's include vector, and we'll probably do something with algorithm at some point as well. So we want to make a new... You guys got video now? You good? You can see this? We're going to make a class called capital I integer, and it's going to look like the integer class from Java, if you're familiar with that. And so we want to, let me show you in main kind of what I have an idea of. Like we can have an integer x that's equal to 5, and we could like cout x, and that should print 5, but that doesn't work. And I'd also like to be able to do something like integer y is equal to x plus 10. You know what I mean? I'd like to be able to basically use the capital I integer class and the lowercase I integer class, built-in type, the int, just an int, like 5 or 10 here. I'd like to be able to use them interchangeably. But with one small improvement, which is that an integer will always be initialized. You cannot have an uninitialized capital I integer. And we can do that very simply here, like that. So we can have a private member variable that is always initialized to 0, and then we need to write some fluff around it to make it behave like it was a integer. And so you can see here, it doesn't know how to convert between an int to an integer. It doesn't know how to add an integer and an int together. It doesn't know how to cout a capital I integer. So we have to teach C++ how to do each one of these things. So we're going to make a constructor, integer constructor that does nothing because the guy here is handling it. What's our warning here? What warning do we have? It's not used. I know, I'm getting to it. Chill. Chill. All right, integer int new x, and we're going to initialize x to new x. Now, in the previous class, a student's like, what does this thing mean? And what it means is we're going to call the constructor on x, the private member variable here. And you might be like, what? Ints have lowercase I, and int has a constructor? Yeah, you can do this. You can say integer, we've already got an x. Let's say apples is initialized to 10. And we can say int bananas is initialized to 20. And we can also say int chocolate equals 30. All three of these ways are ways of initializing option 1, option 2. These are all ways of initializing integers. And so what we're doing here is we're actually just having our constructor call the constructor on x. And this is more or less the same thing as this, which is how a lot of you guys have been writing it. X is equal to new x. It's pretty much the same thing, but there's one important advantage that you have when you chain a constructor together like that, which is that if this was a const, it would work just fine. Whereas if you try doing it the other way, you cannot set x down here. If you try setting x after it's been, if you try saying x equals new x, that will not compile, even if you don't have this thing here. It will not compile. You cannot change the value of x after it's been constructed. It's already been constructed at this point, so you can't change its value. All right, so we have to come back up here and do it this way. Okay, and so this works just fine with a constant. The only way you can initialize a constant member variable is via a chained constructor like that. You guys understand? Does that make sense? My frame rate here seems a little bit low. Okay. Let me see if I can up the performance of my CPU. Power usage is climbing from 30 watts to 90 watts. Frame rate's better? Frame rate's better. All right, cool. I have very aggressive underclocking on my CPU most of the time. So, seems like it was kind of negatively affecting my frame rate. All right. So that's cool. So we got our constructors here. We need a getter and a setter. Let's do that. So let's do int get value, and that's a const method, right? Because it doesn't modify the class. So we're going to return x. And we can have a setter void set value int new x. So x is equal to new x. And of course, that won't work if it's a const. So let's pull that out. Okay. Environmental scrutiny. Definitely not. Like, if you hear my fan is now going because I just tripled the power consumption of my CPU. It's mostly because when you underclock it so much, it is quiet. It's a silent PC. Okay, so we've got a getter, a setter, constructor. Cool. We still can't add an integer and an int. That doesn't work. We still don't know how to see out it. And for any sort of operation like this, you have to tell C++ what to do when you see that operator. Okay, so can we mark it const expr? Const expr this? I don't think so. It's not. Yeah. Okay. Let's see if I can turn this down a little bit. The noise is kind of getting to me. Power wattage dropping from 90 to 40, and it's a lot quieter now. Cool. All right. So any operation like this, where you do an addition or subtraction, oh, the frame rate, great. Anytime you do an operation like that, you have to tell C++ what happens when you see that operator. Okay. So if we want to be able to, let's say, add two different capital I integers together, we have to make a operator integer operator plus that takes in a const integer right hand side. Do you guys know what right hand side means? Like if you ever have like, I don't know, an expression like this, x plus 10, plus is the operator. On the left hand side you have x, on the right hand side you have 10. Does that make sense? Like x is on the left-hand side of the plus, and 10 is on the right-hand side of the plus. Okay. So if we want to have a operator plus that works with another integer, then we are going to return a new one that is rx plus the right-hand side's x. So for example, if we have this, and we said integer z is equal to x plus y, this works just fine. Okay. This works just fine. So what happens here is C++ asks, do I know how to add two different capital I integers together? And now it does, because I've provided it an operator plus. I am the left-hand side. Whenever you have a member function like that, I'm the left-hand side. I'm a capital I integer. The right-hand side is capital I integer. So this is what we do. We add my x together. We add their x together. And it returns that as a capital I integer. And you might be like, but wait a second. What's the type of x plus RHS.x? Anyone know? Anyone know what the type of this is? Yeah, it's a lowercase I int, right? But we're returning a capital I. Okay, unused variable warnings are so annoying. All right. No unused const variable. No unused variable. No unused. Shush. Stop warning me. Okay, so yeah, so this is going to call this function here. And in fact, anytime you have an operator like that, like a plus or a minus or times or something like that, it's literally the same thing. It's literally the same thing as if we had written this. Okay, so when you call x plus y like that, it's actually calling x with a member function on it, operator plus, passing in y as the parameter. You guys understand? Now, normal people don't actually ever write that, right? This is like kind of like inside baseball, like what's actually happening. But do you guys see what's happening here? We're actually calling the operator plus member function on x, passing in y as the right-hand side. Do you guys comprehend this? I don't write code like this, but it's kind of useful to like show you like why x is me, you know, without any, I don't put like anything in front of that. It's just me. It's calling it on me because it's calling operator plus on x. So it's just my x. Oh shoot, I got two x's. Let's not do that. Let's call it value, whatever. S val. Everyone's a val. Valerie. Val. Okay. So it's getting it's x's value plus y's value get added together, then it's returned. But it's returning an int. It's not. You don't love that? Yeah. It's returning an int. It's not returning an integer, capital I integer. And so how is this actually compiling? Because it's returning an int, but the return type is supposed to be integer. And the answer is, yeah. This is not normal, Megan. This is super weird job security code. I don't think ever seen somebody write code this way in like ever. You know, it's just only useful as a kind of a teaching tool to kind of explain what C++ is doing with this. Okay. So, so the reason why this works is because anytime C++ is like, okay, I'm supposed to return an integer and I'm given an int, it asks you, do I know how to convert from an int to an integer? And the answer is yes. The answer is yes. You've actually taught C++ how to construct an integer using a lowercase int. It's right here. Okay? And so if you have a constructor, constructors are not just used, and this is one of the big things for today, constructors are not just used for making a new variable, but it's also used for converting types. So if you have a function that takes a capital I integer and you pass an int to it, it will construct a capital I integer using this constructor right here. It will do one conversion for you automatically, implicitly. Okay? If you do not want this, then you need explicit. If you put explicit in front of there, then it will not do that conversion for you automatically, and you will get a compiler error. Okay. So if you have a explicit constructor, you have to now explicitly say, I want you to convert from this int to an integer like this. And then it works. So this is probably the more C++ correct way of doing things. A lot of people will recommend every one parameter constructor be marked explicit. Parental advisory. Okay. So I kind of disagree though, because for this type at least, I kind of do want it to just sort of automatically go back and forth, you know what I mean, between ints and capital I integers. So I'm fine with it being an implicit one. Okay, but just be aware that a lot of people will take objection to that because they're like, if you want to convert it, explicitly convert it. But I kind of want it just kind of interchangeable with integers. Okay. So coming back down here, yeah, let's get rid of this nonsense here. Okay, so yeah, we don't need you guys anymore. It's in the recording if you want to see them. So we're going to make integer x equals 5, integer y equals 10, integer z. And so that's calling the operator plus, and then we're going to get the value of z. We get 15. Now, what I usually want, though, is just the ability to echo z directly to the screen. And I can do that with what is called an operator, the operator double left arrow, like that. The double left arrow operator needs to take a O stream on the left-hand side. The type of cout is an O stream. It needs to take an O stream on the left-hand side, and it needs to take a capital I integer on the right-hand side. Okay? And then it returns, and I'll explain why it returns an O stream. Why it returns an O stream in a second, but it needs to take in an O stream by reference on the left-hand side, and it needs to take in a capital I integer, and this could be const reference, I guess, integer by reference on the right-hand side. And we'll return out double left arrow RHS dot get value. Just like that. Okay. And so now we have taught C++. If you ever see this operator double left arrow, and it takes an O stream on the left-hand side and it has a, integer on the right-hand side, call that function. And what that function is going to do, it is going to echo the value of z to the screen, because it doesn't know what you want. Like, you have to tell it. Like, whenever I see out an integer, this is what you should print. You have to tell it, or it doesn't know. So it'll see out the value. And then it returns outs. Okay? And the reason why it returns the O stream is because, if you've ever seen this, like cout x followed by y, followed by z, followed by endline, if you've ever wondered how you can chain all those things together, it's because if I put the order of operations on here, let's see here, it's like 3 of those. 1, 2, 3 of those, like that. This is actually what's happening with the order of operations. You don't need the parentheses. I'm just kind of putting it there to demonstrate which takes place first. And as you can imagine, the x gets couted before the y, which gets couted before the z. Double left arrow gets evaluated left to right, whereas equals, single equals, gets evaluated right to left. Do you guys know you can do this? Do you know you can do that? Yeah, you can. And this is equivalent to this. So the equal sign gets evaluated right to left. The double left arrow gets evaluated left to right. So you can do that. You can set a bunch of variables to 0 all at once by saying x equals y equals z equals 0. Yeah, it's pretty common. Okay, so the way that this works is it's going to see out the value of x. So it's going to print, well, let's get rid of that. Get rid of that. So it's going to print out the value of 5. And then it returns cout. And so all of this kind of gets replaced with cout. Aha, look at that. Then it does a cout on y. And then that whole thing there gets replaced with cout. Then it does a cout with z. And that returns cout again. And then that whole thing gets replaced with cout, and then it sees out endline. And so because you are returning cout every time, that's what allows you to chain together multiple cout statements like that. We could have our operator double left arrow return void, in which case we don't return anything. But now look at this. It's complaining about our second double left arrow, right? So we can't even do it here, right? Because you can only have one double left arrow per line if you do it that way. You can do it. It's just kind of tedious, You know what I mean? Like, you cout z, cout x, cout y. You could. It's just kind of annoying. Okay. All right. Let's do that. So do you guys understand why we return cout every time? We pass cout in as a parameter here, and then this whole thing echoes 5 or whatever to the screen, and it returns cout, and then it returns cout, and then it returns cout, and then it returns cout. And that's what allows us to chain together multiple cout statements. Okay. Now, a lot of people would prefer that this be part of the class. And also a lot of people would prefer, instead of having to call a getter, if you could actually just reach inside of the class and print out the value like this. However, we can't, right? Because this operator, double left arrow here, is outside of the class. The only people who have access to the private member variables is things that are within the class itself. And there's a new keyword I'm going to teach you guys today, and that is called friend. Okay, so friend grants access to one's private member variables here. Okay, so if you say, hey, this guy's my friend, you have given them access to your private member variables. Okay, so by doing so, we can now say rhs.val, no problem. The only people who have access to your privates are you and your friends. Okay. So there's a joke in there somewhere. Probably something private. I don't know. Who knows? Yeah. So if you want to grant access, use the friend operator. I actually take it one step further. I actually don't like this being just kind of like hanging out in global space, because really, if you think about this, this is almost like a member function of the capital I integer class, but it can't be. We can't do it like this. I mean, for the plus operator, let me show you guys something else. Let me show you guys. Here's the plus operator, right? We got the plus operator. I could have actually made that plus operator out here in global space. I could have. I would just need to actually make the left-hand side explicit, right? I could have done it this way, and then I would have to type in just.val. This is fine. This is fine. But now this guy, you know, he needs access to value. And we'll have to probably comment this out so we don't have an ambiguity error. And that needs to be semicolon. And there we go. Everything's fine. So I could have either done the operator plus like this, where it's a member function, or I could have done it like this, where it's a global function. If it's a global function, I don't exist, because I'm just a function out in space. So you have to pass the left-hand side and the right-hand side to it. I kind of prefer this version, because it kind of packs everything nicely into one little package. You're like, here's my integer class, and here's all the stuff it can do. Whereas when you have global functions, then they're just kind of like hanging out in global namespace. So I kind of prefer, you know, this is like an option, a global operator function. And the thing about these things is you can't actually make this guy is fine. This guy cannot be a member function, because it would have to be a member function of the left-hand side, which is the OStream class, which you are not allowed to overload. And so there is a trick, a simple trick that doctors hate. And you can do this instead. And now you've got this, that friend keyword there means, hey, this thing after me is actually not part of the class. So even though it's physically located, even though these 3 lines of code here are physically inside of the class integer with the curly boys and everything, even though this code is inside of the class, it's actually still a global function as far as C++ is concerned. But by putting friend in front of it, we're saying, hey, here's this global function that gets access to all of my private member variables, and you can just write the whole thing there. And I actually like coding this way, because that allows me to have all of the operations on my class in one place. What does friend do? Friend grants access to privates. Okay, so here's a learning point for today. Learning point number 1, friend keyword grants access to private members. Okay, so all of our member variables in the private section, it can view, even though it's not part of the class. So even though this guy here is not part of the class, he can still read and write to that private member variable. Okay. The other clutch thing it does, it also lets us put global functions inside of a class. And that's what I'm using it for here. This guy's actually not part of the class at all. It's not a member function. It just looks like it is. Okay. Does that answer your question, Stevie? And that should be const here as well. Now it should be ambiguous. Thank you. Just comment this out. Here should go away. There should go away. No. Use of overloaded plus. Yeah, I guarantee you as well. There. Stevie, do you understand what the friend? What friend does? I know. Computer science. I know. It's hard. It's hard. I know. Making friends. It's the hardest thing in computer science. I understand. So they're still global, but just now have access to the privates. Yes. So anything that's marked friend, this is still a global, but I mean, I've deleted the friend specifier, but yeah, a class grants one-time access, for one particular function. This function has access to val, which normally things outside of the class can't touch. Okay, so what other things could we do here? It'd be kind of cool if we could do, I don't know, this, and that works. You're like, but wait a second. The operator plus takes a capital I integer on the right-hand side. How is it that this works? Science is cool. How is it that our code will work with a integer on the left-hand side and an int on the right-hand side? Anyone know the answer? I've told you once already. Implicit conversion is correct. So naturally, Luke, this would work too, right? X plus 10, 10 plus x, same thing, right? Should work, right? Nope. Because now the plus is on the left-hand side. The int is on the left-hand side, and the int class does not have an operator plus that takes a capital I integer on the right-hand side. So this is where the global version is actually better. So let's go back the other way. And we're going to comment out this person. And now if we put a 10 here, it works. It's an advantage to the global version. Because here you have a version of the function that takes a capital I integer on the right-hand side and a capital I integer on the left-hand side. And now the left side could be converted to a capital I integer. Whereas before, you're trying to call a member function on something that doesn't exist. So the global version, like this is something that you'll see experienced computer science people like talk about, like, all right, which way should we do this? And I like the member function version better overall. But for a case like this where we want it to actually like interoperate with ints, yeah, I'll probably do it like this. Okay. And so now this is a global function. It's not part of the class, but it just acts like it is. And it's in a place, look, it's inside of the integer class. So clearly it's a member function, but it's not. This is the global version of it. Okay. It's just a friend. So this is a friend global function that pretends to be a member function on TV. How about that? Is that a good way of explaining it? Luke, do you understand? It's more symmetrical. I mean, there's that. A lot of people like the global version because it's symmetrical. Okay, so what else can we do? What if we had a function like, I don't know, let's call it like, let's just make something stupid, add int x int y, and it's going to return x plus y. It's something stupid. I'm just, throwing out some dummy code here. Can I pass this x and this y to it? These two guys here. Scout add x, y. Is that going to work? Among Us. You have a feeling it's going to complain? Do we have any way of implicitly converting the other way from a capital I integer to a lowercase I? You think no? You think correctly. There is currently no way for C++ to know how to convert from an integer to a capital I int. So as it turns out, you can write an operator int. And so operator int takes no parameters, and you return val. And let's see here, does that not like you? What's going on here? Oh yeah, because that can be converted to an int now. Now it works. So the operator int is a operator for any time you try converting a capital I integer to int, it will automatically be called, and this will do an implicit conversion between integer to int. And this guy here, constructors, consistors are not just used to make new variables, they are also used to convert from one type to another implicitly. Unless you give the explicit parental advisory keyword on front of it. Okay. So do you guys understand this? That's kind of a cool thing. Not a lot of C++ people know that you can do that. You can automatically convert your type back out like that. And so now we can kind of use these things interchangeably, right? Like we could say, int apples equals z, right? So, z is equal to apples. So we've got capital I integers, we've got lowercase I integers, and they just can intermix however you. In fact, we don't even need you anymore, I don't think. I don't think we need you anymore. And maybe, yeah, I don't think you need you anymore. The reason for that is because it's going to convert both of these guys to integers and then add them in. You know what I mean? Like, so without this plus operator here, we're actually fine because C++ knows how to add a capital I, a lowercase int, I int, and a lowercase int, like a regular int. And so what it's going to do if you say x plus y, it's actually going to convert both of them to integers, just regular ints, and add them, and then save the result into z. So you don't even need most of these things, right? If you have that. So that alone is going to do pretty much all of our heavy lifting for us. All right. What's the advantage of our class? It's never uninitialized. Okay. A regular integer, when you have just regular, int z like that, that's uninitialized. And a lot of students get burned. Like they will write code. They're like, oh, I don't need to initialize. It's too much typing. I'm lazy. Or, I'm sure I'll set it later. And then they forget. And so if you use a capital I integer class, then you can guarantee that your code will never have an uninitialized variable in it. It's nice. And in fact, we could probably comment out almost all of this stuff once we have these two guys here. This allows us to convert from an int to a capital I integer. This converts from a capital I integer back to an int. And now we've just got a very basic, we just got a very basic safe integer class. And anything ints can do, we can do, right? So I don't know, see out that. We can see out what is, I I don't know, 11 modulus x. What do you guys think? What do you think that's going to print? What is 11 modulus x? It is in fact 1. Isn't that cool? Just one simple trick the doctors hate. Our capital I integer class can do, you know, it's just, yeah, anything in it can do, it can do. So for our lab time, we are not going to be using this. I want you to go through the process of actually writing all of these different integers and all of these different operators, rather. Okay, so what other operators are important? Less than. Less than is the other really crucial operator. Most classes I make don't have a plus operator on them. You know, if I make a human class, what does it mean when you plus one human to another human? You're making kids or something? What's happening here? You know, like you got social security records, you add 2 social security records together. Like it doesn't make any sense, right? It's superhuman. Yeah, you merge them together in the condensation cylinder for your pals or something like that, right? It doesn't make any sense, right? So a lot of times operators are like overused. They're used and abused. But for something like an integer class, like it makes sense for a capital I integer class to have addition and subtraction and multiplication, right? You guys with me on this? Like it would make sense. Like for your lab time today, you're going to need to write some other operators like minus. Okay, done. You have to do 4 of these for lab time today. There's 1 of them. You guys see how easy that was? You want to see multiply? You want to see multiply? There you go. There's 2 of them. You have to do 4 operators. I'm not going to tell you which ones to do, but the easy ones are multiply, divide, minus, modulus. You should be able to do these in under a minute for lab time. Okay? It's just free points. I'm giving you guys lots of free points after that group project. By the way, anyone who has not run the RAT program, make sure you come into here and type form. And let's see if this is working. Nope, still core dumping. So, McCarley, are you here? If he's here, I don't know if he's here right now. No. Yeah, for those of you that did not, yeah, you can choose which operators to do. So if you want to take something a little bit more complicated, do like operator plus plus, because there's a prefix plus plus and a postfix plus plus. And I can never keep track of which is which. Yeah. So this doesn't work anymore because we got rid of the implicit conversion, right? So that doesn't work anymore. That doesn't work anymore. That doesn't work. Okay. That doesn't work. Okay. So you're gonna have to implement those things. Do we form a second time? If you've already run it, you don't need to run it again. Just for those of you that have not run the RAT program, make sure that you run it. I was up till 1 last night writing a shell script to collect all of the reports from you guys out of your directories and put it into a folder where you can read them. Okay. Oh yeah. So the last operator that I really want to talk about before I turn it over to lab time is the operator minus. Okay. Operator less than. Sorry. So operator less than is a really, really important operator because operator less than is what allows you to sort. Okay. So anytime you want to sort a vector of integers or something like that, the sort function calls less than over and over. Okay. And so if you do not have an operator less than, then you can create like a custom sort function and something like that. But if you just want your type to be just sortable by default, then you need to write an operator less than. And so it's obviously going to return a Boolean, right? It's going to return true or false. Is the other guy smaller than me, basically? Bool operator less than, and it's going to take in a const integer by reference right-hand side. And we're just going to return, is my value less than the other guy's value? And we're done. That's it. Simple as that. Yeah. So out. Do you guys know what bool alpha is? Nope. This prints true or false instead of 1 or 0. Like if I don't have bool alpha, let me just do both. So if I don't have bool alpha, it's going to print true. Well, it's going to print 1, which is true. And then with bool alpha on, it actually prints the word true. Okay. So that's what that does. It actually gives you the word true. So it is true that x is less than y. Do you guys concur? What about z? Is it true that x is less than z? What do you guys think? Is it true that x is less than z? Yep. T, true, false. Yep. All right, what if I flip the alligator around? Why am I getting a compiler error here? False? Not false, compiler error. Why am I getting a compiler error? Do I have the greater than operator defined? Nope. So, you might ask, like, wait a second. Am I going to have to write a less than operator, a greater than operator, a double equals operator, greater than equals operator, less than equals operator, and not equals operator for every class I make that's like this, that's numeric? The answer used to be yes. And that's one of the reasons why people hated C++. Java removed operators entirely for that reason. But in C++ 20, there is now something kind of magical. It's called it's based on the TIE Fighter, okay, from Star Wars. But they can't call it the TIE Fighter operator or TIE Bomber operator. It's called the auto operator less than equals that. Taking in a const integer ampersand right hand side const equals default. Yeah, look at that. So the spaceship operator, yes, which looks like a little copyrighted by Lucasfilm, now owned by Disney. So it's just the spaceship operator. Because it is going to generate for you. The equals default there means generate the function for me, which is really cool. Most of the equals default things don't do anything. Like they're like if you were to make a auto operator equals const. Most of them do like kind of just boring stuff, I don't know. Or they just like a default destructor just does nothing. But this thing, when you say equals default, it actually generates potentially a lot of code. Yeah. So now down here, this works. This will compile. When you do this, and you say equals default, it generates effectively it generates a less than, a greater than or equal to, a less than or equal to, double equal to, a not equal to for you in one line automatically. So that is pretty rad, and that requires C++ 20. And if you guys are trying to do this on the language server for NVim defaults to C++ 17. Okay, and so you are going to need to update your config file for ClangD to update it to C++ at least 20 or 23. I think I've posted an example in /public/.clang. This was created by Hazelton, who you see on the server. And yeah, so what you're going to do is this. Okay, so all of you guys are going to copy, if you want to use the Starship operator. G++ will compile it just fine because it defaults to 20, but your NVim is going to throw an error on it that's not real unless you do this. So let me put this up on. Yeah, there you go. Yeah, thank you for copying that, Viale. Yeah, so copy the .clangd file from public and put it into your current directory like that, and then it won't yell at you for using the TIE Fighter. Oh. Spaceship. Don't sue me, Disney. Operator. Okay. So yeah, see, this worked. So that generated a greater than operator. I could do greater than or equal. Look, it compiles. Everything works. Everything's neat. Everything's awesome. Not equals. It makes all 6 for you. 1 line of code. It's fantastic. Now, you might ask, well, what happens if you have like, I don't know, val and I don't know, like hit points and I don't know, string name, I don't know, like something like this. Which one does it sort on? Does it sort on val? Does it sort on name? Hit points? How does it know which one is less than another one? And so what this thing does is it's based on the order your member variables are declared. And so the spaceship operator is good for simple classes. Once you start getting into complicated classes, you might actually have to write these yourself if you need, if you wanted to sort on the name first or something like that. You can either put the name first in your member list or write your own less than operator and things like that. But what this is going to do, it's going to write code that basically looks like this. It's going to say, if my value is less than RHS value, return -1. If my value is greater than RHS value, return +1. It does what's called a 3-way comparison. So which returns 3 possible values: less than, equal to, or greater than. Less than is essentially -1. 1 is greater than, 0 is equal to. Actually, technically, any negative number, any positive number is less than or greater than. Okay. So if, now you might think if it equals, now, if they're equal, we get to the tiebreaker. And so the tiebreaker for this thing is the second thing here. And so that's going to be, if my name is less than their name, return -1. If my name is greater than their name, return +1. If my HP is less than their HP, return -1. If my HP is greater than their HP, return 1. If all these things are tied, if we have the exact same value, the exact same name, the exact same hit points, then we will return 0. So this one little bit of boilerplate, and if you can't remember it, don't worry. I tend to just Google it every time because I always tend to forget the const has to be there because the comparison shouldn't change me, right? It could be really weird if you did a plus and the plus changed the variables. Or you added something and it changed the variable. But yeah, make sure you have that const there. I always forget that. So this one line of code here generates all of this stuff for you for free automatically. Pretty cool. And now when you have a operator less than or a starship operator defined, you can now have a vector of integers that is sortable. Vector equals 90, -200, 420, 668, 667, whatever. -3, 0, +200. Okay. So we got a vector of integers now, right? And we want to sort it. So if I say sort vector.begin, vector.end, and we want to print out the whole vector, it'll now be sorted. You guys see how nice that is? So this one little trick the doctors hate, right? That allows us to make a vector that's sortable. If we don't have that, we will get an error, right? We'll get an error because it doesn't know how to compare one integer to another, okay? So, we could do this with a bool, like I said, bool operator less than, taking const integer by reference right-hand side, const, return my value is less than RHS value. That works too. HP is not used, fine. Okay, whatever. That works too. So, it's very common for people to write a less than operator on their class because the less than operator is all that sort uses. You might think, well, okay, what if we have a greater than operator? Nope. Sort doesn't use greater than. Sort only uses less than. Okay? So having a greater than operator does not help you in the slightest. The champion operator is the less than operator. That's the one that allows you to put your capital I integer class through sorting. It allows you to put it into a binary tree, which is always sorted. All these kinds of things that need to put things into order use less than and less than only. Okay? So the starship operator isn't as valuable as you think. But if you ever need to, like here, we're actually making an integer class where it would be useful to know if one, be able to do equals and double equals and not equals, like for sure. In that case, like, because we're making an integer class, like I definitely want to have the starship operator generates all 6 comparison functions for us. So this is C++ 20 and above. Okay. If you are using older versions of C++, make the less than operator, or if you really have to, if you have the stamina bar for it, make all 6 comparison operations greater than, less than, Okay. So that's pretty cool. Do you guys want to see how to make a generic print function that'll work with any of our data structures? Just like that, 3 lines, and this will work with vectors, it'll work with arrays, it'll work with decks. I don't know. I always type faster than the language server can keep up with me. I don't know. It's my gift. Okay, so I can just say print vec like that. And when we compile it and run it, you will see everything is now sorted from least to greatest. Okay. If I change this to a deck, it still works. If I change this to a list, sort doesn't work on lists, but the print still works. Okay. So you can see, boom. So this is just a generic print function that'll work with any data structure. If I make an array of integers, and it is of size, what's that, 7. See that? So this print function here takes any container type, any list, deck, whatever, and it will just say for every element in that container, print it out. Simple as that. And the reason why this works is because we have this guy here that tells us how to see out a capital I integer. So that is the lecture for today. You guys now have about an hour of lab time. The lab time should take you about a minute. So more if you want to do one of the more complicated operators, like the prefix and postfix operators. Like I never remember the syntax for those. Operator plus C plus CPP reference. Like you guys know about prefix and postfix, right? Like int x equals 10. There's x plus plus, and there's plus plus x, right? Not used. I know. Unused but set variable. I know. Hush you. Seriously. Okay, whatever. Isn't that what you're in? Yeah. When I apply to be a professor, like it's surprisingly light on technical questions. And so I was given 5 topics that I could give my sample lecture on because I wanted to know if I could talk English good. And one of the topics was the prefix and postfix plus plus operator in an increment operator. I'm like, that's dumb. Like, who could give a 15-minute lecture, on plus plus and the other plus plus, prefix and postfix plus plus, right? Like that's okay. Shush. Okay. That's pretty trivial, right? 12. Good. That's pretty trivial. Who could possibly squeeze 15 minutes of lecture out of that? And I ended up going through the whole like rigmarole of x plus 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 x, and that's a valid C++ sort of, not really, and that gives us 12. Okay. Expression result unused. Yeah, so x is equal to x plus 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 x is equal to x plus 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 x, right? That it doesn't like, but that's fine. What about that? That it doesn't like. Okay. So this is a valid C++ right there. Do you guys like that? Do you like the that is yeah. So so I lectured on things like that, and I had like biology professors and things like that in there, and by the end of the 15 minutes they were able to like parse all these like horribly there's just pluses everywhere on the screen, just flying at you from every direction. It's like, whatever, we can go deeper, plus 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 plus. It's just things like this. It's just absolutely absurd. And they parsed it, and they figured out what was going on. So this is one of those definite WTF moments in computer science. So anyhow, if you want to make an operator plus plus, it's operator plus plus, operator minus minus, then operator plus plus int, and operator minus minus int. So that's the post increment and post decrement, and these are the pre increment and pre decrement operators. So you need all 4 of them, right, if you want it to behave like an integer. So there's how many operators are there in C++? A lot. You can overload the new operator. I wouldn't recommend it. You can do it. I wouldn't recommend it. It's bad practice. You can do it. I know a company where they built their own standard library and overloaded the new operator, and then new people work there and go, "What is happening? What is happening here?" Is there a table? I think there's a table somewhere of all the different operators. There you go. These are all of the different things you can overload. So for making your little int class, you can do all of these different things here. You can overload the ternary operator. How do we do that? I don't think I've ever overloaded the ternary operator before. Megan, you here? Did you hear that? The ternary operator. We can write our own. We can write our own. I don't think I've ever once overloaded the ternary operator in C++. Other. Yeah, let's see this. Let's do this. Conditional operator. Here we go. Comma operator. Conditional operator. What's the syntax for this? I want to see code. Where's the code? Oh, here it is. Okay. Wait. What is that? No, that's not it. Can we overload it? I don't know. I don't know. I will have to look into that because I have literally never seen anybody ever overload the ternary operator. here. So I need to see if that's possible. I don't know if it is or isn't. Okay. Yeah. So that's basically it for today. So yeah, big takeaways for today. The functions that you overload all the time include like double left arrow, double right arrow if you want to see into a variable. That's very common. Double left arrow, double right arrow, less than operator, and or the spaceship operator. Starship operator, it's a spaceship. Using conversion operators, at least converting in using a constructor is very common. The conversion operator going out is less common. A lot of people don't know about that, where you can convert out to a different type. That's kind of a cool thing, though. And then if your class needs, the ability to do plus or minus or something like that, build them. But like I said, don't abuse it. Like, a lot of people will just go too far and build too many operators, and then their code's unreadable. Like, just like if you're making a fraction class, then yeah, plus makes sense because you can add fractions, you can multiply fractions. But if you're making a human class, a submarine class, what does it mean to multiply one submarine times another submarine? Like, you know what I mean? Just don't go there. Like that down that path lies madness. Making operators for every possible thing, overloading the new operator. It's like you can, you can, but just because doesn't mean they should, right? Your scientists were so preoccupied with whether or not they could, they didn't stop to think if they should. And that goes for operators like times 10. Okay, only make an operator if it makes sense. Double left arrow, double right arrow, sure, everybody's going to have that. Spaceship operator, sure, why not? Operator less than, sure, why not? But for things like this, if it makes sense, if somebody would expect to be able to add two integers together, then put it in. But you don't expect to add two airplanes. It's weird. So don't do it. Okay. So that's my lecture for today. Lab time now is for you guys to write 4 new operators for this class. You can find the code. The code is in /public /I integer CC. Just copy that into your home directory or something like that, and then write 4 new operators for it. Your choice. The easy ones are plus, minus, multiply, and divide, modulus. No, you've already done plus. So minus, divide, multiply, modulus. If you want to take easy straight, do that. You'll be done in a minute. If you want to do something more interesting, like the pre or post increment operators, go for that. Screenshot your work, send it in on Canvas, 10 easy points, then get going on your homework. So if you look in your directory, you will see there are 2 new folders here, 2 new homeworks. One for Fractionation, one for Imaginary Homework. And Fractionation has you making a fraction class. And so you need to be able to add 2 different fractions together. 1/2 plus 1/3 is 5/6, I hope. And Imaginary Homework has you adding imaginary and complex numbers to each other. So 5i plus 2i is 7i. If you do one of them, 10 points. If you do both of them, 20 points out of 10. So this homework assignment here gives you guys a chance to make up a missing homework assignment. And honestly, once you've figured out how to do one of them, the other one's pretty easy because it's all just operators, right? So just implement division. Do you guys know how to do fraction division? You guys remember that? Hey, Ada! Ada! We need the help of the 6th grader. Ada! Do you guys remember fraction division? How to divide 2 fractions? I'm going to call him the expert. Ada, come in here. We need your help with math, girl. So 1/2 divided by 3/4. How do you do fraction division? If you divide one fraction by another fraction.
You just you keep the first number, and then you just flip the second number, and then multiply them.
There you go. So when you guys do the operator divide, On fractions, you flip the numerator and the denominator and then multiply. Okay. So do you know how to add fractions, Ada?
Yes.
You do?
Yeah.
How do you do that?
You just you have to find a common denominator.
The greatest common denominator or the least common multiple?
Common
the lowest common denominator? It's like the least common multiple, right? It's like if we have 1/5 added to 1/7, what is the least common multiple?
I don't really look for the least common multiple.
No?
I don't have to.
What's the denominator then?
I could just do like 35 or something.
35, yeah. I mean, multiplying will give you a common multiple, right? So how many? So this is going to be converted. This is equal to 7 35ths plus 5 35ths. Do you agree, Ada?
Yeah.
And then we get 12 35ths, right? Does that seem right?
Yeah.
Okay. What about reducing fractions? How do we reduce 10 18ths?
Do we simplify it?
How do we simplify a fraction? Yeah.
You have to find a common factor at the top and the bottom, and then you divide it by.
Saying the greatest common divisor.
Yeah.
What is the greatest common divisor of 10 and 18? 2. 2. All right. So we divide both sides by 2, and we end up with 5/9. Okay. But what if we had they have to do it in program. They have to write a program to do fractions. So what about 12 18ths? What's the greatest common divisor?
6.
6. And so that turns into 2/3. Cool. What about 20 24ths?
4.
Huh? 4? 5 6.
Mm-hmm.
Okay. So wouldn't it be cool, guys, if there was a function called, I don't know, greatest common divisor? Wouldn't that be neat? Because that's maybe the hardest part, right? Is finding the greatest common. Oh, wait, there it is.
Yay, they don't have to do the homework now because it already exists.
Yep, exactly. A student was like, I'm going to write a GCD. I'm like, you could.
Mm-hmm.
See, thank you, Ada. Everyone, round of applause for Ada. Bringing in that elementary school arithmetic knowledge. You should know it.
You should definitely know it if you're writing this program.
Yes, but there is in fact GCD already done for you, and LCM also exists, least common multiple. So that's the hardest part, is simplifying the fractions, and with the greatest common divisor, it should be pretty easy. So if you do one of the assignments, you will get CD fractionation. If you do one of the assignments, you'll get 10 points. If you do both, you'll get 20. So if you guys do not have a 100% of this class, I would highly recommend doing both of them and earn some points back, okay? So there's a good chunk of students that don't have an A in this class right now. So here you go. I'm offering you guys this on a platter, okay? So do some math, do some coding. Did you email my professor and give me some extra credit if I do it? Sure. And that is it for today, guys. It is now lab time. Add some operations to the class, and submit on Canvas. And I will hang out here on Discord for a while and answer any questions you have. Peace.